right, so how many numbers are in this list? I mean, nobody wants to write out all the numbers that are in this list. We have 12 fours. We have 11 kids that are age 13. Nobody wants to write out all those numbers, right? I mean, about the best I could do is write this and say that there are 11 of these things. And for 14s, we got 12 of those. But nobody wants to write out all those numbers. How many total numbers are there? Or total data values? Use your calculator right now. So, what is 4 plus 11 plus 12 plus 13 plus 9 plus 7 plus 3? It's over 50, I can tell you that. 59, I got to vote for 59. Can someone verify that it's 50? Yeah, 4 plus 11 plus 12 plus 13 plus 9 plus 7 plus 3. We need to know how many total data values we have. Do we have 59 values? We do have 59 values. Thank you very much. Now, nobody wants to add up 59 different numbers, so we're going to try to do this a little less painfully. We have 12 people that, or I should say we have 4 people that have an age of 12. Plus 11 people with an age of 13, plus 12 people with an age of 14, plus 13 people with an age of 15, plus 9 people with an age of 16, plus 7 people with an age of 17, plus 3 people with an age of 18. Of course, to find the average, we're going to divide that by 59. But how much is that? What is the sum of all 59 numbers? I got to vote for 871 on the top. Can someone else verify that the top is 871? Don't wait for someone else to be doing this. You need to have a calculator or Desmos. You need to be typing. Somebody else does your work. They might as well get your pay. Yeah, that's how the world works. If someone does your job for you, they should get paid the money. Is the top 871? Okay, so we got 871 for the top, 59 for the bottom, and that gives me an average of 14.76, 14.8, something like that. for the median, remember we would take the number of values and divide by 2. Number of data values and it's either going to go one direction or another. You're either going to get a whole number, in which case it's the average of that one and the next one. So it'd be the average of 2 numbers in the middle. Or we're going to get something 0.5. In that case, round up to find that value. Unfreeze this. We're back. Okay, so did we get a whole number or something 0.5? Alright, what did we get? 29.5. Round up to find that value. If you take 29.5 and round it up, what do you get? It is the 30th data value that we're looking for the median. The 30th data value. Okay, so we know the first 4, right? The first 4 are all 12s. That is obviously not the 30th data value. So I'm going to go to the next group, which is all 13s. There's 11 of them. Have we gotten to the 30th one when we add 4 and 11 data values together? Nope, that's the 15th. So we're still not up to the 30th one. So now we go to the next category. We add 12 more. What's 15 plus 12? 15 plus 12. 27. Now we're up to the 27th data value. Still not the 30th. So the 30th one must be in this group, and it is a 15. Therefore, the median is 15, right? The 30th data value is a 15. I mean, like I said, nobody wants to write out all these numbers. So you have to logically think through this. Well, you got 4 of these, 11 of these, 12 of these. So the 30th one has to be in this group. Now, which group occurs the most often? Is it the 12s, the 13s, the 14s, the 15s, the 16s, the 17s, or the 18s? Which group occurs the most? It's the 15s that occur the most, right? Because there are 13 of them, and that's one more than the next group. On question 2. How many data values do we have? Count them out. Tell me how many there are. I got them written in order for you. 20 of them? Okay. What would you multiply by to find the 40th percentile? 0.4, right. Now, this is going to tell me a particular spot in the data. And the next one is obviously 0.6. Find those 2 spots. Now, those are the spots in the data. Those are not the actual answers to the question. Those are the spots in the data. Hopefully you came up with the 8th spot, 8th value, and what else? The 12th value. Okay? Now 8 and 12 are not the correct answers based on what I see so far. So, start at the bottom. First, second, third, 4th, 5th, 6th, 7th, 8th. The 8th data value is a 7. right? This is the 8th data value. We're looking now for the 12th data value. 9th, 10th, 11th, 12th. Is it a coincidence that the 12th data value is the number 12? Yeah, total coincidence, folks. Has nothing to do with the value being 12. It's the spot in the list that you're looking for. Okay, the next question, you will need Desmos.com. You will need the graphing calculator version, not the scientific version. Please go to the graphing calculator version of Desmos. Step 1. L equals bracket. Must be a bracket, not a parenthesis. That's why we have these things written in our notes. Then go ahead and enter all the numbers. With a comma separating them, does not matter what order they're in. This is question 3. We did 1 and 2 already. I'm recording so it's there for it. It appears that there are 10 numbers in the list. What do you think we need to type for finding the mean? Well, stats, if you do stats, that's good for box plots. So we'll hold on to that one. So stats L, like this, great for box plots. Great for 5-number summary. And box plots. But that's not what we're going to use this time. Okay. So what are we going to use? Mean. Parenthesis L. Yeah, that'd be a good idea. Find it. So mean, parenthesis L. Well, that's pretty easy. We've got 9. What instruction do we use for variance? VAR. And then how do I go from sigma squared to sigma? How do I get rid of this square? Square root, right. So to go from this one to this one, we need the square root of that 22.89. 0.78. Pretty straightforward, folks. Use the bracket when you're creating the set. I know, I mean, you gotta have all the numbers. Those are brackets when you're typing in the set, but then when you're typing in these other things, you're using parentheses. Yes. Okay. Any other questions on that? That's what you're saying too? Okay, hold on a brief moment. Okay, so the page that's missing is my fault for not copying it, so I will get copies of that for tomorrow. But we'll get questions 10, 11, and 12 knocked out here. A point in the figure is chosen at random. Okay, so this is that that giant dartboard at the bar that you, if you can't hit that, then you're definitely, you're no longer allowed to drink anymore. Okay? Because this thing has an inner target of 6 feet and an outer target of 10 feet. So you really should be able to hit it. Then, yeah, that means you're really gone, man. Okay, so what are the two radii? 3 and 5, thank you very much. Yeah, you cut 6 and 10 in half and you get 3 and 5. Just like we did back in geometry. Alright, so area equals pi r squared. That's our circumference, or our area formula for a circle. And if you want to find the ring and divide by the total, we have to take the big circle minus the little circle. That gets us the ring. And divide by the big circle. Well, this is the only way, not the other. Okay. Well, you started singing the song one way or another. I said this is the only way, not the other. But you didn't even listen to it. My goodness. So the big circle, what's the formula for the area of the big circle? Right, so that would be pi times what? 5 what? Come on, follow. 5 squared. We know that that gets copied in 2 places in my formula. The very first part on the top and the bottom. Minus the little circle. What's the area of the little circle? Pi times 3 squared. What is 5 squared? 25. So we have 25 pi minus 3 squared, which is 9 pi. And on the bottom, of course, is 25 pi. Find me the final answer as a fraction or decimal. Okay. What is 25 take away 9? I mean, aren't those like terms? We could just subtract them, right? What do we get? 16. Does anything cancel out of this? Anything that you see in the top, you also see it in the bottom, and you can get rid of it? Oh, the pies. I asked you for either a decimal or fraction answer. Is 16 over 25 a fraction? So that is one of the acceptable versions of this answer. Now, another one would be 0.64 for you decimal fans. Yep. Well, if you're going to do that, especially on your scientific calculators, I would suggest you do it like this. Yeah, people forgot the parentheses, and then it ended up giving them all kinds of weird answers. Yeah, so, I don't know. Question 11. There's 153 students in the class. Yeah? Okay. I probably do not have time for whatever this is. What? Yeah, that's what I thought. Yeah. Okay. In a class of 153 students, 97 are taking math. Now, you'll notice that right here, this does not say 97. But right next to it, if you take 54 and you add 43 to it, you do get 97. This entire circle is 97 students. 78 students? Well, that doesn't say 78, it says 24. But if you add 54 and 24 together, you get 78. In other words, they separated things for you. These are the kids who are taking both. These are the kids who are only math. These are the kids who are only science. What about these 32 kids? Neither. They're not taking math or science. They must have gotten done with all their math and science credits. Okay, so they are asking me the probability of taking math or science or both. How many kids are in that group? Math or science or both? How do we calculate this? Add what together? I do agree with you, that is one way to do it. What do you want to add together? $43, yes. 54 in the middle, yes. And 24 on the right, yes. These are the three numbers we would add together. Out of how many total students? 153. Cypress, figure out what that numerator is. And Rupert, you do the same so we can double check. Did you get 121? Okay, good. One acceptable answer for this question is 121 out of 153. I did teach you another way you could do this question. You could take the 32, you could take the 153 students and subtract the 32 and divide by 153. Guess what? You get the exact same result. So we could take the number of people who were not taking a class, a math or a science, away from the total. That would still give me 121 students. So take your pick as to which one you want to do. Depends on how you like to think about it. If it's easier for you to add, you can add these three numbers together. If it's easier for you to subtract, I mean, it just depends on what kind of person you are and what you like better. Some people like this other way because it's, one thing on the top and they're done. Okay, last question here for today. A group of 40 students from your school is a part of a television game show. The total number of people in the audience is 120. So we have 120 people, and this audience is being split. There's 40 from my school and 80 other people. Now, they're going to select 9 people for the game show. 9 people total. So the bottom of this is going to be in combinations. This is number of 9 people groups. Why is that so loud? That noise that I'm hearing out of somebody's earpod. Number of 9 people groups out of 120. That's the bottom. That's the total of this. But then we're going to split the top into 2 parts. Out of the 40 students in my school, it says, what's the theoretical probability that 5 students are selected from my school? That would mean 35 are not. If you pick 5 of them from my school, that's 40 people from my school, and we're choosing 5 of them. We have 80 people in the other group. How many of them got selected? 4 of them, right, because 5 plus 4 makes 9. 9 total people. That means 76 of them did not get chosen. But the key parts are the parts that I just circled. Out of the 40, we're picking 5. Out of the 80, we're picking 4 of those. Now, we can finish the calculation on this tomorrow, but we need to make sure we get the correct number on this. I'm going to do it on my calculator just so I have it, but we need to make sure we start tomorrow and double check that. And I'll just leave it. We'll start tomorrow with finishing this. Okay, so I think we were finishing question 12. We had gotten this far. We knew that we were splitting the 120 into 2 groups, 40 from my school, 80 other people in the audience. Out of these 40, they wanted to know what's the probability that 5 of them are chosen from my school. Since they are choosing 9 total people, 9 total are chosen, that means that 4 of them would be from the rest of the audience. Now, I have a feeling this is going to be a small number, because you're only choosing 4 out of this group of 80, and you're choosing a larger amount out of a smaller number. So, I have a feeling this is going to be a very low percentage, but we're going to find out. Now, the total number of groups of 9 that you can pick out of the 120, that is your denominator. Now, it depends on how your calculator is set up. If you're using something that's vertical, or if you're using something that's horizontal. So if you're using something that's horizontal, you would type 40, and you would find your NCR feature, and 5, parenthesis, 80. So it just depends on your calculator. Oops. But make sure you use parentheses when you do this kind of thing. Otherwise, you won't get the correct answer. And I do want everybody doing this on either a calculator or Desmos, whichever you prefer. And I'll I'll be happy to write out those instructions as well. But please make sure that you're doing this. Here, if I was doing this on Desmos, I would probably do N capital C lowercase r parenthesis 40 comma 5 parenthesis. We'll put parentheses around that, and then another set of parentheses NCR parenthesis 80. This is for Desmos if that's what you're using. So I'll write that here, Desmos, and then I think you could use either one for this particular thing. Scientific might be easier, not have to mess with the graph because there's no graphing on this. But this is how I would do that on Desmos. We need to all come up with the same value, so please make sure it should be under a little bit under 10%, which is actually surprising to me. I thought it was going to be lower than that. So no matter which way you typed it, you should be getting this number, 0.0995. Now, obviously, if you round that off to the tenths place, that would be 0.1, which is pretty close to. And if you're going to show me the work, I'm not going to argue with you if you round that to 0.1. Anybody have a question on that one? Okay. And now for the missing page. So, first order of business is to type all of this stuff into the calculator or into the desmos.com/calculator. Okay? So, get to the graphing calculator. There are 11 items, 11 data values. Make sure you have all 11 of them. I'm going to split my screen now. So we typed in our data set, L equals bracket, and all 11 data values. We typed mean L to find the average, 113.09. And then to get our 5-number summary. Now, I have seen people doing this. And then they look at me and they say, Mr. Staley, it's not giving me the 5-number summary. What's wrong? They forgot it's plural. Then they do this. Mr. Staley, what's wrong? I can't get the 5-number summary. I'm like, well, stats is not spelled like states. No, I've seen it done in back when we did it in the first. So, I just want you to realize it's stats. That's why we write things in our notes. So you don't look at me and go, it's not giving me the 5-number summary. Okay. And what did she say? Okay, good. Awesome. One less thing to think about. 68, lower quartile, 40, upper quartile, 119. Range, that's the max minus the min. Max minus the min. Okay, so, Norman, what'd you get? 547 minus 28. 519 it is, that's true. Interquartile range, IQR is Q3 minus Q1, that's the edges of the box from the box plot. So So 119 minus 40. 119 minus 40. Watson, what do we get from that? 79 is correct. Please make sure you have your notes filled out for that. Now, there's not enough room to show you how to do question 5 on answer blank 5, so I'm going to flip to the back side of this page and do my work. You will need Desmos pulled up, so please make sure you have Desmos ready to use. Okay? And we can just use the graphing calculator version that's right here. Alright. I mean, it works on the scientific one too. Question 5. So, just so you have a visual of what we're doing, this is called a normal curve, which we talked about already in when we did the chapter before. And the middle of that is the average, which in this case is $22.07. That's the average. That's the mean. It's right there in the middle. If I go 1 standard deviation up and 1 standard deviation down, you would have to add $2.75, since that's the standard deviation. They told me at the beginning that the mean was 22.07 and that the standard deviation was 2.75. And if I go down 1 standard deviation, that is subtraction of 2.75. So as we said, we were going to do this 1 standard deviation at a time. So we're going to start with 22.07, and we're going to go up and down from that spot. So on the high side, we're going to add, and on the low side, we're going to subtract. Okay? This will be within 1 standard deviation, and that's that little sigma thing, which is their symbol for the standard deviation. What do you mean, which one is it? So, this 275. Okay, so we're taking our 22.07, or you can do it over here. Let's just do it on this. 22.07 since it's easier to see. Standard STD. Could be stud. Or yes, it could be sexually transmitted diseases, but it's standard. Okay, alright, you do that. Okay? Just so you don't get confused and think that we're dealing with diseases. He's not a disease. He is a disease. What? He used to be. Maybe to the Boston Celtics, sure.
Let's say he's...
Well, I'd say we're probably all in that game. So, we get 1932 on the low end and 2482 on the high end. So, are all data values inside this range? That's the question they're asking me. Are all the data values between $19.32 and $24.82? Flip over the page and start looking. Do you see anything that's outside of that? Yes, one there, and one there. There's 3 values that are not inside of that range. So we have to keep going. So now we're going to subtract 275 again, which means that we're going down 1 more. We're also going to be going up 1 more. So, we'll just take these values and repeat the process. 1932 minus $2.75. 2482 plus $2.75. So my new boundaries are 1657 and 2757. Now I can ask the question again, are all data values inside this range? Because it was a no on this one. What about this one? Well, except for that $29 one. So that's still a no. So we need to do one more. Minus 275 plus 275. So this was 2 standard deviations, and we said no to that. So now we're checking 3 standard deviations. So 1657 minus 275 and 2757 plus 2.75. Looks like I get $13.82 on the low side and $30.32 on the high side. Now I'm going to ask the question again. Are all data values inside this range? That's a yes. So we now know the answer to the question is 3. It wasn't 1, it wasn't 2, but it was 3. I'm telling you to go in order 1, 2, 3. What if it stops at 1? I'm not going to waste my time doing 2 and 3 if it stops at 1. What if I get to 2 and the answer is 2? I'm not going to waste my time doing 3 if I know the answer is 2. But clearly we had to go all the way to 3. And so this is a 3. And yes, you do need to show me work. There'll be more space than what's provided here, because that's not enough room to show all that work. Does anybody need any more of that? Hopefully you copied it down as we went and not just read email. Come on, pay attention, right? There's lots of stuff to write down. I promise you, you won't go home and do all this by watching a video, even though I am recording this. Okay. We got, they want to know about the number of different ratings. Now we're moving into the probability section. So out of the stats section and into the probability section. So I should probably bring this back. Okay. Until we need that calculator. So we want to know that how many different ratings there are. This is all about the multiplication counting principle. So we will be multiplying this stuff together. We have 2 levels of price, 3 levels of repair frequency, 2 levels of features, and 2 levels of picture quality. Okay, so that's multiplication. What is 2 times 3 times 2 times 2? 24 it is. And that's as easy as that question is. Don't make it more difficult. We literally have 2 options, 3 options. So just look at it and see what it says. I mean, if it says 4, then you put a 4. If it says 5, you put a 5. And then multiply them together. So that one is just as easy as it looks. Multiplication counting principle, I just shortened it to MULT. But yes, multiplication counting principle. Question 7. Do we know whether this is a permutation or a combination? How did you know? It's told me. Right here, folks, it tells me in the question. Use permutations. Okay? whenever they talk about lineups or arrangements, typically that means permutation. The next one uses the word arrangements, but we're going to see that's a little bit different. Okay? But we have 14 bands, but only enough time for 5 of them. So that's 14P5. Or if you're using another type of calculator, 14NPR5. Or if you're using Desmos, NPR parenthesis 14, comma 5. One of those needs to be used based on your calculator. It will be a fairly big number. Over 200,000. Rogers, what'd you get? $240,240. If that's what you got, you are correct. Yeah, it just depends on what your calculator, or if you're on Desmos, it's going to look like this. And different calculators look like one of those too. So. Okay, the next one's the flower arrangement one. Do you care what order the flowers get placed in the arrangement? No. Order does not matter. If order doesn't matter, that's a combination. I know they use the word arrangement, but that's a common term for flowers, floral arrangement. It has nothing to do with the order that the flowers are placed in the arrangement. So, we have 18 flowers, and we're choosing 4 of them. So, figure out what combination that is. And what are we getting? Over 3,000? Inu Marua, what'd you get? Okay, let me look at your calculator. Well, I don't know what to do with that, because every time I come over there, I'm like, what's going on? Alright, so 3,060 is correct. Sure. Such a good friend to ask us to wait for him. Okay, good. Question 9. A marble is selected at random from a jar containing 40 red marbles, 50 yellow marbles, and 10 green marbles. How many total marbles are there? 100. So we all know the denominator is going to be 100. Okay? Now, They're asking me for red or green. Is it possible that you could be red and green at the same time? We're going to draw one marble out, and it's red and green at the same time. With the marbles that we have in this, are we able to select from this jar and get one that's red and green at the same time? No. Now, I know there are marbles out there that, are swirly and all that good stuff. But they didn't give me that option, folks. So, it is as simple as adding those two things together. And what are we getting? What'd you say? 2? I don't think, you can't have more than 100%. I got an answer of 0.5. Is that true? Oh, really? Do tell. Would I accept the answer 50 out of 100? Would I accept the answer 1/2? Would I accept the answer 50%? Yeah, they're all the same. Oh, learn something. Yes, really. I know. Okay, so that's all the notes that we have for this. Oh, do we want to start? Okay. 5 minutes. Look who's bad at subtraction.